ChatGPT and GenAI tools have hit the mainstream. The chatter was everywhere, by almost everyone. We feel the discussion has been more philosophical than practical. We know enterprise technologists are using real AI to create efficiencies that result in real business outcomes. So, we created a show to talk to real practitioners about real-world active projects that are leveraging this exciting new technical advantage. Welcome to LiveAI.
We are back for another episode of LiveAI, the show that brings practical enterprise use cases to you. I'm very excited to have with me in studio today, Greg Statton, who will be discussing the use of AI in a multinational manufacturing corporation. And he is joining us today from Cohesity. Welcome to the show, Greg.
Thanks, Tony. I'm excited to be here.
Yeah, great to have you. It's great to do something in person again for a change.
I will come and do this any day of the week. This is like literally 20 minutes from my house.
All right, 6 more episodes then, locked in.
Sign me up.
You know, when I heard that this project involved using AI to help sift through a massive, global data retrieval pipeline, my curiosity was pretty piqued. What can you tell us about the company you're working with, and what were they looking to do with AI?
Yeah, so we were working with JSR Corporation, and they are like a hardcore material sciences company. Like they invent and build polymers. Very different than anything we've ever worked with. And they came to us with this big problem. They're a multinational company. They have research and development offices or labs kind of across the globe. And each one of these labs kind of works on experiments and new materials kind of independently. And their board said, we want to be able to more easily share knowledge across all of these different R&D silos. And they didn't have a good way to exchange that information outside of bulk copy a lot of these papers over. And I think as well as I know, if somebody hands you 1,000 PDFs, are you reading every 1,001 of those PDFs?
Maybe half of them.
Maybe half. I'm doing
maybe 10% of them.
I'm doing a whole lot of Command F to search for keywords, and it's not a really effective way of sharing knowledge. And so the CIO there is a really good kind of forward thinker, and he was like, hey, with all of this advancement in AI and with kind of semantic indexing, this whole concept of retrieval augmented generation, why don't we figure out if we can create these semantic indexes of all this research data? And their security and safety were kind of like their big kind of core pillars, because this is like core IP to the company. And if we could do that to help share across these different regional sites. And so that's what they came to us with, that sort of problem. And we worked with them to kind of help kind of code design and code develop the original launch of our solution, Gaia, to help deliver that.
So there was no solution for this at the time, right?
No. Well, so there was. You could build your own. So, and they started doing this. They said, hey, we can go out, we can go grab a vector database, we can grab an embeddings model. They've been working with Microsoft and with AWS on language models and hosting infrastructure. And they started to piece this together a little bit. They had this big aha moment, though, where data truly does have gravity. Mm-hmm. And the amount of money they were going to have to spend to copy all of that data up to a cloud provider to be able to run that, when they were already paying to kind of store that data it was on our platform on Cohesity from a backup perspective. They said there had to be a better way. And so this was very early on. There started to be some of these RAG as a service companies. Sure. But one of the kind of the core problems was it couldn't run in the cloud. They had to control where the data lived because of there's a lot of crown jewels.
The client did.
Yeah, the client did.
So who makes the discovery that leads to this questions of like, can we use our Cohesity data to go help fuel this? Like, what's the background of that? Because when I think about developing like an application or solution to something, and even if you had a whole room of people like trying to brainstorm this thing, you probably wind up in the same spot. Hey, we're gonna spin this up in AWS, Microsoft. We're gonna find all the data. We're gonna have to figure out the classification, the sensitivity level. Then we're gonna put it in this one place, and then we're gonna leverage that information. And then how did the Cohesity angle ever come into this?
It was almost kismet at the time. we were doing an EBC for the client, and they came into our office, and we're just kind of getting the general update from our leadership, from engineering, from support. And I was at a point in kind of piecing together the original parts of Cohesity Gaia, and we can kind of talk about that in a second to bring all this together. And I was at a point where I wanted to start getting some validation from the field. And so I reached out to our account team, said, hey, any EBCs that are coming up with kind of some pretty forward thinking, executives, I would love to share what we're working on to kind of get some validation and see if we could kind of partner with them. We love doing design partnerships with clients because it really helps short circuit that initial validation.
Yeah.
And we want to be able to build things for people. And so they said, sure. And I came in and I gave this kind of high level demo of it fully running off of my laptop at the time. And they said, this is really interesting. You're using Cohesity data. I said, yeah, since the beginning of the company, we've always had this North Star vision of enabling our customers to re-leverage their own data to drive operational efficiencies. And you can say that, and a lot of people will say they want to re-leverage things. And we tried to do that along the way. We gave people the ability to back it up. They could clone it for test dev. They could use our platform as a file system. But now there's something really interesting. All that data is there. You're already storing it. And we built a file system. We can recover data pretty rapidly. We can provide role-based access control access to it. Why I kind of had the idea, why can't I create a semantic index of this? Why can't I then provide API access to that semantic index? And why can't we just pair with any language model provider?
Sure. And
that was that. It was kind of the right place, the right time for us, the idea and the client.
So let's dive into this, what a design partner is, how that process works, and how you guys took this, fortuitous meeting where, you had an idea, they happened to have a problem and said, hey, this could be a thing, but you don't have anything that is, enterprise grade, that you're, even close to being a GA. This is more like an idea, and you're looking for a design partner. Because I would love to take us through how you guys think about design partners, how this one specifically, turned into what ultimately became a capability that other clients now can use, and then give us an in-depth on what it actually is, because I think this is really interesting and a really novel use of information to solve a key problem.
Yeah. So design partnerships, it's a really interesting relationship between us and a client where we really do bring them into the fold. There's a kind of a group of engineering leadership, product leadership, and then the customer. We don't bring the sales teams in a ton because we're not trying to actively sell them at this point.
Sure.
What we're trying to do is we're trying to bring them along on the initial ideation, the initial product requirement documents. We'll bring engineering in to discuss some depth of design. We don't want to bore them with the full low-level engineering design, but really what we want to understand is hey, what are the core problems that they're having in this space, and kind of list those out. Then we kind of make sure that, hey, in our initial product requirement doc, are we addressing all of these? And then we kind of go back, work on that design doc, and then we come back and say, hey, this is the wireframes of what we're thinking. What do you think? And then we kind of walk them through some of the flow, focusing in on some of their core problems as user stories. And then we'll kind of get sign off this is a part of the problem, or actually we had some other new problem, can you augment this? Or they'll give feedback on wireframes, and then we go back and then design and build, and then we start delivering kind of early versions of the software. And this is what we did with JSR. They saw an initial prototype on my laptop. I kind of built and coded this up to run on my laptop, talking to a Cohesity cluster in our lab, and it was not pretty. I'm not going to pretend to be a designer. Definitely not going to pretend to be a developer. But it was working. They liked it. So then I shared with them kind of our initial design documents. They say, yeah, this could work. So then we launched our first beta version, and we enabled it for them, and we had them use it, give feedback, and kind of continue to iterate until we got to a point where we said, hey, we feel that this is now kind of at a good place to be GA.
Yeah.
And then we launch it, and they get to continue to use it as a production fully supported feature. So it's a fun, stressful, exhausting, but extremely rewarding process.
Oh yeah. Well, I know we keep referring it to it, and maybe it's time that we,
Dive
jump in a
in.
little more depth of like, okay, when you say it, so they had this problem.
Yeah.
They were already kind of building their
Yeah.
own. They see this cohesity prototype of
Yeah.
something. Like, what is that thing? And then how did that come to be like the primary choice in how they wanted to solve this problem?
Yeah. So when I'm referring to it, I'm talking about Cohesity Gaia, which is essentially a retrieval augmented generation, or RAG, which I still really dislike that term. Like, I think it's a terrible term, but that's fine. Retrieval augmented generation system and pipeline that's leveraging all of the data stored on Cohesity as kind of a repository to create these on-demand index of embeddings, or this on-demand semantic index of this
And
data.
for those who don't know, if you're storing data on Cohesity, you're generally talking about
It's your backup
Your
data.
backup data.
It's your backup data. And I'm trying to kind of move a little bit further away from saying backup data, because I truly believe there's a ton of value in that data. One thing that's interesting about backup data is the only system in your data center where you're automatically kind of collapsing silos onto a single platform. And it's the only place where all of the data from your entire enterprise is stored in one place. It could be different locations and whatnot. And one thing that's extremely interesting about backup data is it has a component of time. With a system like Cohesity, where we've kind of redesigned the idea of backup from the file system up, we have the ability to kind of sift backwards and forwards, not into the future, but up to present point in time.
I was like, wait. When are you going to IPO again? No, I can't talk about that.
but you can shift back and reimagine what the enterprise looked at any given point in time. And that becomes really interesting when you look at different use cases to be able to kind of satisfy different needs. And so, with this data that's sitting there, like with traditional backup systems, you're paying this premium, this insurance premium, to store that data in the closet and hope you don't need it.
Sure.
And you need it in the event of like a natural disaster, or somebody deletes an email, like your boss, and you need it back quickly, or unfortunately, cyber crimes.
Ransomware,
malware can go wipe out entire application stacks or data centers. So you're going to do this, and you're paying a premium for it, and it becomes really expensive. But if you can start re-leveraging that data without disrupting its primary intended purpose, it kind of reduces the cost because you're gaining additional value out of it. And so that's why I think it starts to make more sense of re-leveraging it more and more, so that you can kind of reduce that perceived cost of the backup solution, but then also just enable new functions more rapidly because you already have the data.
So when you think about this architecture then, so you have the backup data, it's already sitting there. You're leveraging it for a variety of reasons, but ultimately, you've got multi-version control, you've got the ability to look back in time. The data itself that's sitting there is immutable, because any new copy that comes in is going to be like a new copy, not a replacement of the existing. What about, I guess, so how does that work then? So like I just have a bunch of Cohesity appliances or software running somewhere. I've got all the data sitting there. You're spinning up a vector database outside that environment and then exposing a portion of that data based upon how I want to design the application? Or
Yeah, and so that's a really good question. And you describe Cohesity so well. If you ever need a job, I'm more than happy to. But in all seriousness, you have, like a lot of our customers are managing petabytes of data, or at least hundreds of terabytes of data on Cohesity. Now, creating a vector database of this, and not to get too deep into the weeds, but a vector database, they're kind of interesting. It's not like a traditional relational database or document database store. It keys off of like a whole massive number, it's actually an array of large numbers, it takes up a lot of space, and it takes up a lot of memory. It takes up a lot of compute to run this. So it's not efficient to go say, hey, I want to take all of this 100 petabytes of data, shove it into a vector database, because it's astronomical, the amount of space that consumes. When you create a vector index of data, more often than not, it's 1 to 3 times the logical footprint that you're already storing inside, just to store the vectors. That's kind of an aside. So what we wanted to do was give our clients the ability to create kind of what we call this on-demand index of embeddings, to be able to select subsets of data across space and time, or locations and backup. I just like Doctor Who, so I like to say across space and time.
Sounds much cooler.
It sounds so much cooler than talking to your backup data. So they're allowed to kind of select those data sources, and you pick the time, either the most recent, so it could be from like 2 hours ago, or 2 weeks ago, or 2 years ago, or 10 years ago. And you kind of put all of that data into a shopping cart. Then you say, all right, these people can access that. So you can apply finer grained role-based access control on top of that. Then you mash a go button. Then what happens is we take that data and we read it from the backup. We then pass it through an embeddings model, which is a fancy transformers model. It's an AI model, which then takes the text input and calculates this embedding, which is a semantic representation of the data, just how the words feel together in a string. And then we store that on a vector database that's all kind of managed in our data plane. So it's kind of all kind of safe and secure within that tenant. Right now it's on our as a service offering. We're working on bringing that on-prem to kind of give customers a choice of where they want to run this stuff. And then we can pair it with a language model, because now we focused on the information retrieval side. So once that data is indexed, we can then now take an input query from somebody, or either from a person or from another system, and then return the most semantically relevant pieces of data or documents. And then on the platform itself, which is what JSR was using, our Gaia application, we've partnered with Microsoft in the initial release to bring Azure OpenAI to this. And so we then take those retrieved chunks of documents, wrap it in a prompt with the user's question, send it off to the language model. It comes back with an answer along with citations. And so now you can not only get an answer, but it's providing the exact documents that were used to help generate this.
So how quickly, and I guess what degree of responsibility do I have as a client with the capabilities you're bringing to me? And then let's assume that Microsoft is like the partner of choice, Azure OpenAI. I've got like ChatGPT or something like sitting on the back end. How do I get to like a finished application that's actually running? Like, how much more is there to do?
So for a lot of our customers and clients, they can just go and purchase Cohesity Gaia if they have already a Cohesity customer, and that's everything. So it's got everything all packaged up neatly, and that's going to work for probably 80-90% of our clients out there. Some of our other clients are going to say, hey, you know what? I've got my own language model. It's fine-tuned on our own internal vernacular or our own lingo. Can you use that language model instead? And so we have the ability to then go in and say, hey, we're going to point somewhere else. Or, like I mentioned, we're going to start giving customers the ability to run this stack, in their own environment, whether it's their own cloud tenant or on-prem. But there is the easy button, and that's just, buy it. It shows up. You can do all the indexing through the UI, provision and allow people to be able to ask questions of that data, or use the API to plug it into Slack. Like internally now we have Slack bots that just talk back to Cohesity Gaia for all like our HR docs and stuff.
Oh, okay. That's interesting. So like explaining like that chain of events. So like that's to service your own employee population.
Yeah. So I can go into like any Slack window and I can just do Slack/ask HR, and all of our HR policy documents are then, because we back up everything at Cohesity. All of the
I would certainly hope so.
I just wanted to put that out there for anyone. We do drink our own champagne, so to speak. But like all of the HR policy docs, all like the travel and expense docs, they're all indexed. And through, just because we're API first, we just wrote a Slack bot that talks to that. And now that we've combined with Veritas, we have a Teams bot as well. And so you can I don't know how to do it in Teams. I haven't fully migrated over yet, but we can integrate that into any of the other systems, and it's still all kind of using the data and security primitives that are kind of buffered by Cohesity.
So what do you think the advantage is then? Like, let me just give you like a few kind of like scenarios.
Sure.
My HR documentation is already sitting on a SharePoint somewhere.
Yeah.
The security controls are already in place. I can use a variety of different methods to, create my own access to that. Whether it's, competitive solution that's all in, or like building our own, whether, maybe even like Copilot Studio.
Yeah, absolutely.
Why build that through something like Gaia versus what I have, like sitting in a store already like that?
No, and I get that question like literally all the time. And I personally don't think it's an either or. I think it's actually a both. And we've been working with Microsoft, actually with all of the kind of the major cloud providers, because they're all getting into the same space. I think they realize that unless you're like a very modern, super small company, the likelihood of 100% of all of your data living in a single cloud is very low.
Very low.
And so the ability to access that data that happens to be on-prem or in a different location or in a different cloud, without having to wholesale move that data to that cloud to use like the Copilot plugin, is pretty interesting to Microsoft. It's interesting to us. And I think most importantly benefits the client, because now they're not going to have to deal with keeping data in sync, paying for the 4th or 5th copy of that data just so that they can integrate it into a chatbot.
Yeah. What's interesting is I remember you and I, you're local to us, obviously. That's why great to have you in the studio today. You and I met when this was still, something that was in development.
Yes.
Like you came to the office.
Yes.
You were, showing off like some of these concepts running on your laptop. Like, hey, this is what we're thinking. And at the time, the first thing that came to mind to me is like killer use case for this like exactly what you were building was, hey, look, e-discovery and related activities.
Yes.
The tooling that was out there, like you're going to run a whole separate platform, or could this snap into that workflow and ultimately just like supercharge it?
Yes.
And, since then, the acquisition of Veritas.
Yes.
And, so I guess I'm curious, like, cause I do think that there's this tremendous untapped potential of your backup data, for lack of a better term, is sitting there and you're paying for it.
Yeah.
Why not get tremendous value out of it?
Yeah.
And where are the areas where it makes a lot of sense in the beginning to, step into that quickly, because, both from like the controls that you natively have in there and like the versioning controls and like all the other benefits that we've already talked about, are there a couple or a few like kind of killer use cases that you guys are, or maybe it's still early stage, but you're starting to see like things move in a certain direction?
Yeah, I think it's both. I think there were some things that we initially thought were like, oh, this is going to be awesome, everyone's going to love this. And then we're like, where are the customers? And then we've been engaging with more and more clients, and we're like, we want to be able to use this solution to do ABC. And we're like, oh, we never thought of that. That's actually really interesting. Initially, when we came out, we said, all right, this is a brand new space. Nobody in data management, data protection is talking about this. We have some like 1,000+ startups that we're spinning up around RAG as a service and RAG solutions and chatbots. And we said, hey, we want to focus in on kind of 3 core use cases because we operate in a larger enterprise. And it was knowledge management, e-discovery, and like compliance use cases. And we thought the e-discovery and compliance were going to take off very rapidly, and they're starting to now. I think some of it is we're used to talking to the IT teams.
Mm-hmm.
And so kind of, talking to the chief compliance officer is tough to kind of make those connections. When we do, it becomes really interesting. Like we had our own internal compliance and audits teams test out and use Cohesity Gaia on kind of known cases that they've had to do. And we said, hey, this is great because we can take that data, we can silo it off, give these known people permissions to this data, and you can go ahead and ask questions. And actually they found it reduced their time to final findings report significantly. Now it's not a drop-in replacement for existing e-discovery solutions, but it actually helps reduce that time to kind of creating the findings report. I can sift through that pile of needles looking for the few golden needles that are in there very, very rapidly. Knowledge management, I think, is right now within the IT functions is a killer use case. And I kind of keep thinking back to my time in the enterprise. I spent the bulk of my career in enterprise IT. And some of our clients are now starting to kind of go ahead and do this. They're taking all of their like internal documentation around a new workload, feature, operating system, whatever they're going to go deploy, which usually, like when I wrote these, it was a mix of our deployment guides, a mix of all of the vendor specific documentation, and kind of like troubleshooting guides. And these were like work packages that I'd have to turn over to operations. Operations would stand this up and then would go to support. The worst thing would be a year later, somebody from support filing like an L3 support ticket and me picking it up on a solution that I hadn't worked on in a year or two. Or even worse, my colleague who has since left the company.
Right.
And they created all this work package. So like what some of our customers have been doing now is they've been taking all their IT docs, indexing them all, giving access to support and to ops. And we've seen early stages, we're still kind of early validating this, but we've seen a pretty significant reduction in total ticket creation to help kind of the lower level engineers. And they're reducing the time to resolution on some of these tickets. And actually some of our own internal SREs and our support technicians have been using some of Cohesity Gaia's features to help reduce the cycle times on delivering fixes to our own customers.
Yeah. Well, and I think that's an interesting like segue and kind of like my next question, which is, where do you think this stuff goes next? Because, you're kind of building foundational capabilities that are going to lead to the next thing.
Yeah.
Like if I've got this knowledge management solution, I've connected it into this ability to be able to interact with it and have it, help me at least identify and find information more quickly. But then you think about even like that same support story of, well, what about taking action?
Yeah.
What about, the ability to help me, craft support workflows for new products and do that very quickly? Because the documentation portion, the training portion, and then like the follow-up support for anyone who's working in enterprise IT. This is like the bane of the existence of, you're like, I want to get back to working on stuff, not, doing all this piece of it.
Yeah.
But, at what point in time does this become, like we keep talking about AI is like the thing versus no, this helps facilitate solving these problems. But then where's that technology going next? And like, where do you think, these foundational capabilities with things like Gaia, as you guys are working on now, like what happens next that kind of supercharges us into the future?
Yeah. I think unless the listeners and watchers have been living like on Mars ahead of us, everyone's been hearing about agentic workflows or agents. And they're super interesting. And kind of to touch on your like take action, it's still, as much as everybody's talking about it, it's still very much in an early stage of being able to take action. I think anybody who's played with agents outside of like a very specific narrow use case will find that they fall off the wagon like really, really quickly, or they'll spiral out and iterate very, very quickly into infinity and provide zero value. But right now, what we've been doing early in this GenAI kind of revolution is trying to get a hold and a wrangle on data. And I think that's the foundation for anything that's around artificial intelligence. So once we can get a better handle on data and labeling that data and understanding that data and cleaning that data, we have these models that can then now synthesize actions out of it or synthesize recommendations out of it. And I think the next part is being able to figure out, how the AI starts to fit into the solution. I think everybody's very worried about like AI is going to replace all of the jobs.
Right.
And if anybody's ever tried to use AI to create any sort of like script or coding, they'll realize that's not going to happen anytime soon.
Not soon.
Not anytime soon. And there will always be the need to have the human in the loop. Because I, for one, wouldn't want, like I could give an AI agent full API access to manage my Cohesity infrastructure. I would never give it like API delete commands, or I'd very rarely give it put commands unless it can validate with me. And so being able to figure out what these systems can and should operate on, where the human needs to be involved is going to be extremely important. But where is it going? I think you're spot on. It's how can it integrate into these solutions? And if I had the exact answer, I'd probably be on a yacht out back there. But I think you're spot on. It's all right. We have data. We can kind of reason through situations. Like we have a known problem from an error. Like we use our tech doc example.
Right.
We have an error that's come into a system. Well, now the system can stitch together like, hey, based upon all the documentation, I can come up with steps to like realize what we should do to remediate it. The next thing would be have the AI remediate it for you. Like I think right now we're in this world where we're prioritizing a chatbot and this turn-by-turn interaction. I don't want to have a chat with it. I want it to know what I'm going to need when I'm arriving at a page in a user interface.
Right.
Or if there's an issue that the system has detected, why can't it do all of the research in the surface and say, hey, you had these 5 errors. I was able to remediate these 3 but with simple KB articles that we found already, and they were easy fixes. They were non-destructive. These 2, we need you to fix them. Here are some recommendations. And so I think we'll slowly start to chip away at some of those actions. And we'll start with the easier ones, the non-disruptive ones. But the human should always be kind of involved in that.
Yeah, I mean, it'd be interesting to see how it all shakes out.
It will be.
I know there's a ton of startups too, specifically working on that space to where, every week there's some interesting new breakthroughs and things that are going on. I did want to circle back and just make sure we close the loop. You opened this talking about this, use case with JSR and isolated working groups with their own, silos of information, wanted to be able to, create a solution that allowed the sharing of that information and, preferably being able to search through that information for things you're looking for. What was, I guess, where did we end in the end? What results did they see? And what kind of benefit did we drive from the solution?
Yeah, the early results were, the very early initial results were kind of mixed. And I expected that because we were now working with very scientific data that happened to be originating in Germany, in the US, in Japan, and
was
China.
it also in those native languages?
Some of those in those native languages. And so they were like, hey, if this is all in English and all the data is in English, like it works. It's great. I can get some good summaries. Now, one thing with retrieval augmented generation, which I think a lot of people don't necessarily think about, is this concept of recall. And so, not to give any sort of math lessons, I'm underqualified to do any of that. But there are two main kind of metrics that you look for in an AI system. It's the precision and the recall. From a recall, it's like of everything possible out there that I could potentially pull back, how many did I pull back? And because we're the way that vector databases search, it's not like a select star from this table where this field is equal to this.
It's kind of conceptual.
It's conceptual. It's like, hey, I've got this crazy multi-dimensional space and there are all these points in there and my query lands here. Show me the 4 or 10 or 15 or 20 most related documents to it. So it's not going to get everything.
For anyone who's still confused, I mean, like the original use case that makes a ton of sense is like if you're looking at this t-shirt, here's like 20 other pieces of clothing that are like similar to that. And that's, kind of like vector magic at work on the back end.
Or summarize, the conversations that Tony and I have had about AI in our email or in documents or in news publications. It's going to snip those paragraphs or those several paragraphs out, get a decent understanding semantically of what we're talking about, and then write a summary.
Yeah.
Some people need I need everything. And it's that kind of that concept of a database query. And so, there would go through some of these kind of questions and answer like, well, yeah, this is not necessarily wrong. It would be great if it also added in these other sources, but they were just semantically outside of that kind of bubble, or I don't know what you call a bubble in 384 dimension space, but let's just imagine it as a bubble. And so they said, can you fix that? And so then we went back and said, hey, how can we expand this this search space, providing more references to the model to help generate better answers? And so it's still like an ongoing iterative process. But I think, and these weren't necessarily problems that the client was aware they were going to hit. And I think these are things that we didn't necessarily think they were going to hit. And that's why the design partnership was so important. So they initially kind of went out and said, hey, this is good. This works okay. Then they started to kind of onboard other use cases, kind of like the IT use case or meeting notes use case, where I've got these cache of large quantities of notes from various times and spaces. And while we're still kind of addressing that initial one, they still see value in the solution and have found kind of other use cases to solve for, maybe not as massively grandiose as unifying research across an entire kind of multinational company, but we're working towards that still.
Now, how do you solve for the multi-language problem?
Yeah, so that is, it's actually it's kind of simpler than what we would have thought. There's that model that we were calling an embeddings model, and what that does is it takes text or image, or audio or video, whatever you throw at it. The one we're working with is text primarily. And then it outputs a tokenized representation of that data in a vector array format. And whatever language space and vocabulary that embeddings model is trained on is what it's going to be able to tokenize. So you can have documents that have mix of language within it, and it's still going to be able to tokenize and output a vector representation of that. And so we moved to embeddings models that can support more than English. Some of the early embeddings models, especially some of the smaller dimensional models that were faster, cheaper, and easier to run, were only English.
Right.
And that's great for us living here, but that's terrible for like anybody in the rest of the world, which is the majority of the world. And so by iterating on these components, we're able to kind of support more and more things. The language model is the same thing. These LLMs have been trained on a much larger vocabulary, so they can then output in whatever language they're told to, or whatever language the incoming references are in.
Now, so if I then am a team member in the US and there's this other data store that's sitting in Japan somewhere, and it's all in Japanese. Mm-hmm. Your embeddings model is overcoming the ability for me to be able to, basically like retrieve information.
Yes.
And find what I'm looking for.
Yes.
And then, but I still don't speak Japanese.
Correct.
So like my answer would be in English of like, hey, here's like a summarization of like what you're looking for. Here's all your reference docs.
But your
and
reference
then I click
docs,
on it and then like,
it's
congratulations, now you have to learn Japanese.
Yes. So I mean, that's the beautiful things of like the transformer model architecture. I mean, it was first invented as kind of a language to language translation model by Google, that architecture. And so it's actually really good at being able to do that. So then the next thing to do is like, all right, now I want to translate this Japanese document to English or to French or to Spanish or to German.
Which, essentially is not that big a deal. Then
it's
once you have the document you're looking for, do the translation.
Yeah.
But consuming all those different languages and being able to do the embeddings without having to translate everything to English first.
Yes.
As like this ingestion workflow.
Yes.
Has basically allowed you to keep doing what you set out to do, which is this data is already sitting here. Let's make use of it, versus having to create a whole nother set of data somewhere. And then that's like the foundational waste to go create this application that we're looking for.
And, that was always our big kind of marketing spiel at Cohesity since day one, is we wanted to kind of break down all those data silos. Like, why keep 5, 6, 7, 8 copies of data? You should have your primary, your secondary. Use them as you want. But yeah, exactly. Why keep creating all these copies of the same bits?
Yeah.
Just reuse the data you already have.
Awesome. Well, Greg, it has been a true pleasure having you today. And I love that you're local. I mean, welcome back anytime. Like next time you guys do like a major capability change, we'd love to have you back.
Yeah.
And, just easy hop for both of us down here to the studio.
It is.
For those of the rest of you out there, this has been another great episode of LiveAI. Until next time, see you later.
You've been listening to LiveAI. We hope you've enjoyed the conversation. This episode is sponsored by Trace3. To learn more about why you should connect with them, about your enterprise practical AI use case, visit them at trace3.com or look for them on LinkedIn. Thanks for listening.